we need to talk about ISO. Hi everyone, Emil Husson here. Thanks for joining me. Today I want to talk about a little workhorse in the camera called ISO. It's probably the least glamorous because you don't get a lot of fancy effects out of it. You can't get buttery bokeh. You can't soften the waterfall with it. All you can really do is make those other functions work for you by getting just the right amount of light into the camera by using your ISO control properly. So let's dive right in and talk about 5 facts about ISO. Fact number 1, ISO originally applied to film. In fact, back in the 1950s, it was called ASA for the American Standards Association, which is now ANSI, which sets a lot of standards for things like machine parts, screw sizes, and things like that. But when the film standard was started, it was applied to the sensitivity of film. So, for example, if you wanted to pick a film that was going to be used during bright daylight, you would pick an ASA 100 film, load that into your camera, and go out and shoot, and hope that you didn't have to shoot indoors or in a darker condition with that camera before you used up that roll of film. I remember seeing some professional photographers who would run around with 2 or 3 cameras because each camera had a different ASA film in it. And so if they were shooting in daylight, they'd whip out the ASA 100 camera and shoot with that. Also, when you loaded the film, there was a dial setting on the camera that told you what the film speed was. And then you could make all your settings adjustable to that film speed. And so the camera would help you gauge that. Later on, you would dial that into the more automatic film cameras, and they would help you get the right amount of light for each setting with shutter speed and with aperture. But suffice to say, ASA started out as a film standard, and then in the late 1970s, it shifted over to ISO, and then that standard became applied to the sensors in digital cameras. Now, fact number 2 is, as I've alluded to, that ISO is part of the exposure triangle. In other words, working along with aperture, working along with shutter speed, ISO helps you get just the right amount of light for the exposure that you want. That means that you can, set to capture wildlife. You want to freeze a bird in flight or capture an animal that's off in the woods somewhere. You want a high shutter speed and probably have a small aperture so that you're not worrying about whether or not that animal is going to move in and out of the depth of field range that you have. So you want to set a higher ISO. So when you put the 3 legs of the exposure triangle together, you can come up with just the right formula to get the shot you need. Fact number 3, ISO is an international standard. It's ISO 12232 to be exact. When ISO was first applied to film standards, it was actually ISO 6. Now, you may have heard of ISO in terms of business, in factories. It's used in standards for quality. It's used in standards for reliability, for safety, for energy efficiency, and many other management concerns. ISO is actually managed by the International Organization for Standardization. So why isn't it called an iOS standard? Because since they are international and they operate in a number of different languages, iOS would be a whole different set of initials in French or in Spanish or in any other language where iOS operates. So what they did was they came up with a single word that would apply across the board. They went to Greek, which is, number 1, foundational for a lot of language, and number 2, it's very scientific. So they picked the word isos, which means equal. So now the ISO standard means that it is going to be equal across all nations that follow the standard. This makes it easy to ensure that any camera that's manufactured with these standards is going to have the same response to light. You can carry the same settings across any camera and be sure that you'll be within an acceptable range of getting that image that you want. So if I use a Nikon, I could pick up a Sony or a Canon and know that if I set to ISO 400, I know exactly what I'm going to be getting. Okay, number 4. ISO is not an indicator of sensitivity. Well, not in a digital sensor anyway. It did indicate sensitivity in film. In a digital sensor, however, each camera has what's called its native ISO, which is the ISO where that sensor operates without any amplification. That's usually ISO 100. If you want to go above that, then you're going to have to amplify the signal that's coming out of that sensor in order for it to read properly.
To understand this better, it's good to know how a digital camera sensor works. The sensor itself is made up of millions of pixels collecting red, green, and blue light. As the light hits each pixel, the material in the pixel releases electrons in proportion to the amount of light hitting it. Those electrons are counted, and the result is converted to a voltage that the camera circuits can read and, when combined with all the other pixels, assemble into an image. The difference between the minimum number of electrons the pixel can count and the maximum is the sensor's dynamic range. Any fewer, and the pixel says it's black. Any more, and the pixel maxes out. Ideally, you want every part of your image to release enough electrons in every pixel to be counted accurately. But if there isn't enough light, you have to amplify the voltage output uniformly across all of the pixels so the camera has something to work with. This is what happens when you increase the ISO. The problem is, as you increase the voltage, you're also increasing the response to those electrons that don't normally get counted. That's the noise. The more voltage you add in, the more they count, so the more noise you get.
So, for example, if I go to ISO 400, I'm amplifying the amount of signal that comes out of that sensor to indicate the light that was coming into each pixel. But in amplifying that signal, I'm also amplifying any noise that was in there. That's why, as the ISO increases, the noise increases. Now, the signal-to-noise ratio has gotten a lot better lately. I remember the days when ISO 800 had unacceptable noise in still cameras. And now we're going up to 6400 and sometimes even higher, and we have an acceptable amount of noise for most images. Number 5. It's better to have your ISO slightly high than it is to have it slightly low. What do I mean by that? Well, in certain situations where you only have one shot to capture the image, for example, wildlife photography, event photography, street photography, you may want to make sure that you have the entire dynamic range captured. And digital cameras are more sensitive at the high end of the histogram. They capture more detail at the high end than at the low end. So if you set your ISO slightly high and you use raw settings, you're able to recover more detail out of the light than you would be trying to recover it out of the dark if you had your ISO set too low, because then you'd be introducing noise again. This is an excellent location for demonstrating what I'm talking about. It's dark, there's wildlife around, but it's very fleeting. I managed to capture one small baby bird. I can't quite tell what it was, but we'll maybe identify it once we get into processing. But we have the conditions where I needed a very forgiving aperture, so f11. I needed a higher shutter speed, so I had to go to a high ISO. So I went to a slightly high and then a slightly low ISO. One you would think would give me better quality because it's a lower ISO, but the other one pushes the histogram to the right so I can try to recover those hot spots, and we'll see what happens when we get into post.
So it turns out that what I thought was a baby bird was actually an adult pied-billed grebe, which the guidebooks say looks like a chicken and acts like a duck. But I digress. Let's get to the point of this whole exercise, which was exploring the difference between the high ISO overexposed and the low ISO underexposed to see which is going to be preferable. So I got this scene a few seconds apart by switching the ISO. The low ISO was 2500. The high ISO was actually 12,600. So it's kind of an extreme gap between the two, but it will really illustrate the point. So the first thing we want to do is try and bring these down into some kind of normal. So what we'll do is we'll go into develop mode, and we'll take down the exposure until we're somewhere in the normal range. We're not going to crush the blacks, but we'll get out of the overexposed range. And now let's go to the underexposed version, and we're going to bring that up to about the same level. And let's just check it out and see how close we are between the two. So they're fairly similar in effect. So you see that I was able to recover, this is the overexposed version, you see that I was able to recover these highlights pretty nicely. There's no cliff over here in the histogram, so you know that we were able to recover the highlights. But the real test is when we get in close to look for noise. So I'm going to go up to 400%, which is more than anybody would ever want to do in a print or even in a digital image. And you can see this is the overexposed version, and there is noise, obviously, but at 12,600 ISO. But let's look at the underexposed version at 2,500, which you would expect to be much better. And you can see there's about the same level of noise. This is overexposed. This is underexposed. And we even need to recover some more of this in order to get to the same level. Overexposed, underexposed. So what we see in this demonstration is that there's no appreciable difference in overexposing at a high ISO and underexposing at a low ISO when it comes to the amount of noise, even with that massive difference between the two, 2,500 versus 12,600. All that to say, it's better to overexpose and then bring that image down in Lightroom or Photoshop or any of your other post-processing software, because you can recover those highlights better than you can recover the shadows. Another way to illustrate this is to look at a couple of pictures that I got at Reykjanes in Iceland with the wonderful sea stacks. Now, these pictures aren't going to win any awards, but they will illustrate my point. These pictures were both shot at ISO 160. The overexposed one was at 1/30th of a second at f5.6. The underexposed version was at 1/200th of a second at f5.6. So you would expect that the noise level would be about the same. But again, let's look at when we try to match them up, bringing down the overexposed version first. So let's just kind of get it centered, and we'll rescue some of the shadows just so that we have a little bit of interest there. And we'll bring down some of the highlights so that we can see that there are highlights to see. Again, there's no cliff here on the right side, so we know that we got everything that there is to get. Now let's look at the underexposed version. And we're going to have to raise that up and already we have to rescue some of the blacks, so we'll squeak that up just a little bit. And again, we'll bring up the shadows the same way. Let's see, do those match up? The overexposed version has been corrected a little dark, so let's, just for the sake of argument, let's bring those shadows up a little bit. Okay. Now the sky in the underexposed version is still pretty hot, so we'll bring down those highlights just to make it fair. Now they're pretty close. So now let's go in and look at this at 400%. Okay, this is the underexposed version, and you can see there's a bit of noise there, even at ISO 160. Now let's look at the overexposed version that we brought down, and it's a lot cleaner, a lot cleaner. So the point here is, if you have the opportunity and you only have one shot, it's better to overexpose, either by cranking up the ISO if you have the exact aperture and shutter speed that you want to meet, or by using your exposure triangle to get a slight overexposure that you can then bring down in processing. This all assumes that you will not be able to do bracketing and exposure blending with multiple shots.
So, if you have to make a choice in situations where you have a very broad dynamic range that you're trying to capture, try to shoot slightly high, get that histogram edged a little bit to the right, and then recapture that in post-production. So I hope you know a little bit more about ISO than you did when we started. If you like this, go ahead and hit the like button. If you want to see more when I make it available, hit the subscribe. And if you want to find out when I make something new available, go ahead and give that bell a little whack as well. Thanks for watching. I'm Emil Husson. See you next time.